Hi friends, this is Nishant here. In my video tutorial, I will be describing the different stages of generation of an executable file from source codes written in C language with respect to Ubuntu operating system using GCC compiler. The different stages of the process are shown in the figure. The source codes written in C with an extension .c is first fed to the preprocessor, which performs inclusion of header files by providing their paths, expansion of macros, removal of comments, unwanted new lines and spaces, and thus conditional compilation. The preprocessed output will have an extension .i. The second stage is compilation. The compiler checks for any syntax errors in the high-level preprocessed output and converts it to low-level assembly language. If native compilation is done, the assembly code generated with an extension .s will contain the mnemonics of the processor that is used in the system. The assembly language file is converted to machine-readable object codes by the assembler, which is the third stage of the process. The object code with an extension .o containing a stream of ones and zeros can be read by hex code editors or readers. A complete project may be written as a number of modules, that is, it may be splitted into a number of C codes. Each code need to be converted to object codes. These object codes along with necessary library files are linked together by the linker to generate the final executable file, which will have an extension .out. Let me show you the different stages of operation with an example. Tutorial 1 is a project folder. I have divided my project in the two modules, display and sum. Both folders contain a C file that I have prepared in advance. Let's have a look at the C codes display.c and sum.c. The display.c file have the hash include stdio.h, which is inclusion of the header file, void sum.pgm, which is the declaration of the sum.pgm function, which is defined in the second called sum.c. The main function contain two printf statements and a call to the sum.pgm that I have told it is in the sum.c file. The sum.c file also contains the hash include stdio.h for inclusion of the header file, a definition of the b value for adding, definition of the sum program into a is equal to 5 comma sum a equal to a plus b, where b is defined here and a value is initialized as 5, and a printf statement to print the sum of these two. Now we can form the different outputs, that is sum.c can be converted to sum.i, then sum.i to sum.s, sum.s to sum.o, and in the same way we can convert the display.c file to display.i, then display.i to display.s, display.s to display.o, and these two object files, that is display.o and sum.o, can be linked together to form the final executable file here. So let's convert both the files display.c and sum.c to the respective object files. First I am taking the display folder and opening the terminal. Here the code for conversion is GCC space, so I am using the GCC compiler with an option -E for performing only the preprocessor operation. Display.c -o, that is print to the name specified. So I am giving the name display dot I. That is, once again I am explaining the thing. GCC -e for preprocessor only option, display.c which is the input file, -o to print to display.i, and press enter. So you can see here the display.i file is created. We can open it with any text editors. And the beginning of the preprocessed output, we can see the different paths of the header files, and at the end of the preprocessed output we can see the small code that we have written in the display.c file. Secondly, we can convert the preprocessed output to the assembly output, assembly code, by typing gcc -s, which is the compiler option, display.i space -o display.s. The display.s also can be opened with a text editor. We can see here it contains the mnemonics, third stage is assembling. For that we can type gcc space -c space display.s space -o space display.o to create the object file. The object file generated here cannot be opened with a text editor. It can be opened with any hex editors. In this case I am using a ghex application. Here you can see a stream of codes, hex codes, which contain only ones and zeros. In a similar way, we will be generating sum.i, sum.s, sum.o. First, for generating sum.i, gcc space -e space sum.c space -o space sum.i for generating the sum.i file. I am opening the sum.i file for showing you the macro expansion, where we have written the value of b, it is replaced by the value. That is, in the C code it was written as sum equal to a plus b. Here the b value is expanded as 10. Next, gcc space -s space sum.i space -o space sum.s, the assembly code. Then gcc space -c space sum.s space -o space sum.o for generating the object code. So in the two folders we have the sum.o file and the display.o file. These two object files are needed to be linked together with some libraries to form the executable, final executable file. So I am naming the final executable file as project. So I am opening the terminal from here and typing gcc space, as we have to link the display.o file and sum.o file, which are inside display folder and sum folder. I am giving the path display bar display.o space sum bar sum.o. This is for linking the display.o file and this sum.o file, and linking together to the output file, executable file, project.out. You can see here the executable file is found. In order to execute the executable file, we can type /project.out, then press enter. We can see the bit of the output expected from the first program as well as the second program. The printf statements are from the display.c file, and the function called to print the sum is in the display.file, and the function is inside the sum.c file. So sum.c file output is here. So these two object codes are combined and the total output is generated. Thanks for watching my video. If you like my video, please subscribe my channel. Thank you.